Hello everyone, welcome to Chemazon-Complete Chemistry. So this is a part 4 of the GATE 2023 chemistry paper. So this is the first question that we are going to discuss. It is from quantum chemistry. What is given? The wave function of B3 plus. B, what is the atomic number? It is 4. So what is the electronic configuration? 1s2, 2s2. So for B3 plus, what is the electronic configuration? We will remove 3 electrons. 2 electrons from 2s and 1 electron from 1s. So it is 1s1. So this is similar to hydrogen. So we can call this as hydrogen-like atom. Okay, and what is given? This is the radial wave function of the radial part of the radial wave function that is given. N is the normalization constant. R is the distance of the electron from the nucleus. A naught is the Bohr radius. We have to find out the most probable radius. Okay, 4 options are given. So now this is the formula for most probable radius. Let us first see how can we solve this question using this formula. Okay, it is n square by z into a naught. Z is the atomic number. So for beryllium, Z is what? Z is equal to 4. And n, how do you get n? This is the wave function and this is the general form of the wave function. If we compare this given wave function with the general, this is the general form, we can get the value of n. What will be the value of n? You can see Z R by n a naught. So n here is 1. So n is 1 and Z is what? Z is 4. So what will be the most probable radius? Most probable radius RMP will be n square by Z, that is 1 square by Z is 4 into a naught. Okay, so the correct answer is going to be a naught by 4. So this is by using the formula. Suppose you don't remember the formula. So how can we solve? The proper solution is we have to solve by using the radial distribution plot. What is a radial distribution plot? It is 4 pi r square psi square. Psi is what? Psi is the radial wave function. Okay, so what we do for finding out the most probable radius, we derivate with respect to radius psi square r square, that is the y-axis of this radial distribution plot, and we equate it to 0. Then we will get the answer for the most probable radius. So we have to first find out this expression psi square r square. So r square psi square is equal to r square into psi. Okay, we have to do psi square. So psi is n e raised to minus 4r by a naught. We have to do square of this. So what do we get? R square. This will be n square into e raised to square of this, means minus 4r into 2r. So that will become minus 4 into 2 is 8. So minus 8r by a naught. Okay, so this is the term for size r square psi square. Now we have to differentiate this with respect to radius. Okay, so d by dr of n square r square into e raised to minus 8r by a naught. Now n square is the normalization constant, so we can take it outside. So n square into d by dr of this. Now this is one function and this is another function. First is the quadratic, second is the exponential. So we have to use u into v rule. So what is that? D by dx of u into v is what? First you keep the first term as constant, u into differentiation of second term plus, then you next you keep the second term constant, v into d by dx of the first term. Okay, this is the formula of u into v rule. So first we will keep r square as constant into d by dr of e raised to minus 8r by a naught into e raised to sorry, plus e raised to minus 8r by a naught into d by dr of r square is equal to 0. Okay, n square is constant. Okay, now we can solve this. N square into r square into d by dx of e raised to x is what? E raised to x minus 8r by a naught into differentiation of this exponential term d by dr of minus 8r by a naught plus e raised to minus 8r by a naught into differentiation of r square is what? Okay, I can write here d by dx of x raised to n is n into x raised to n minus 1. So here it is x square, or we can say r square. So r square will be 2 into r raised to 2 minus 1, that is 2r. So differentiation of r square is what? It is 2r is equal to 0. Okay, so what is the differentiation of minus 8r by a naught? Minus 8 by a naught, I can take out constant. Let me write again, n square r square e raised to minus 8r by a naught minus 8 by a naught is constant. D by dr of r will be 1 plus e raised to minus 8r by a naught into 2r is equal to 0. Now what I can do, okay, now I can take, you can see 1r and e raised to this term. I can take common. So what will I get? N square is already outside. 1r e raised to minus 8r by a naught I have taken constant. What is remaining here? R into minus 8 by a naught is remaining plus here if you see what is remaining, 2 is remaining. Okay, r into e raised to minus 8r by a naught is constant. Now this entire term, if I bring it on the right hand side, it will be divided by 0, so that will become 0. So I can erase this term. Okay, now we have to solve this. So this will be minus 8r by a naught is equal to plus 2 on the goes on the right hand side, it will become minus 2. Okay, so minus and minus sign gets cancelled. What will be r? This is r most probable that we need. R most probable, that is most probable radius will be 2a naught by 8 is equal to a naught by 4. So that is the correct answer. Okay, by using this method also, if you don't remember the formula, just differentiate this term and equate it to 0, we can get the same answer. So what is the correct answer? Correct answer is option B. Now let us see the next question. This is a question of consecutive reaction. P gives Q gives R, and this is the concentration for Q that they have given. P0 is the initial concentration. Value of K2 is given. K2 is 25 second inverse, and we have to find out the value of K1. Okay, so what is the formula for Tmax? What is the formula for Tmax? The formula for Tmax is, so the formula for Tmax is ln of K2 minus ln of K1 divided by K2 minus K1. Okay, so for finding out the value of K1, what we need is, we need the value of K2 that is given to us, but Tmax is not given. Okay, so what we can do is, you might think that you might do either differentiation to this term and somehow find the value of Tmax. So by differentiating and equating to 0 only, we get this term. So the only way to solve this problem is, we have to substitute all the values of K1 into this formula and find out the value of Tmax, for which the option where the Tmax will be maximum, that is going to be the correct answer. So let us solve for all the options. Okay, so for option A, for all the options, value of K2 is same, that is 25 second inverse. Okay, K1 is 20 second inverse. So Tmax will be ln of K2, that is 25, minus ln of K1, that is 20, divided by K2 minus K1. 25 minus 20. This, if you solve, the answer comes out to be 0.045 second. Okay, the unit of this is second inverse. So that is how the final unit comes out to be second. Now B, again K2 is 25 second inverse and K1 is same, that is 25 second inverse. This, if I substitute, T max is equal to ln of 25 minus ln of 25, that is 25 minus 25. This is going to be 0 divided by 0. This we cannot solve, that is not defined, because 0 divided by 0 we cannot solve. So option B is incorrect. C option, K2 is equal to 25 second inverse, K1 is equal to 30 second inverse. So T max will be equal to ln of K2, that is 25, minus ln of K1, that is 30, divided by K2 minus K1, 25 minus 30. This comes out to be 0.036 second. And D, K1, sorry, K2 is how much? K2 is 25 second inverse, and what is K1? K1 is 35 second inverse for the last option. So T max for this will be ln of K2 25 minus ln of K1, that is 35, divided by K2 minus K1, that is 25 minus 35, is equal to, this comes out to be 0.034 second. So what we want is, we want the longest waiting time, that is the maximum value of T max. So which is maximum among these three values? 0.045. So the correct answer is option A. Okay, let us see the next question. So compound P was prepared based on four component reaction. What is the meaning of four component reaction? You take a beaker or a reaction vessel, you take four reactant all together. Okay, all together we take four reaction. That is why it is called as four component reaction. Okay, at room temperature in methanol, we have to find out the starting materials. The product is given to us. This is the product. This is which reaction? This is a named reaction called as Uji reaction or Ogi reaction, whatever you want to pronounce. So here, which are the four reactant involved? One is isocyanate, that is RNC. Okay, this is the isocyanate. Next is amine. Then we have carbonyl compound, that is one is carboxylic acid and there is an aldehyde. So we get this compound. Now the question is, if we don't know this reaction, obviously most of the people would not remember this reaction. Even if you have studied, you will not remember this reaction because the mechanism is very complex. Okay, do you have to write down the mechanism for solving this question? So the answer is no. It is a 1 mark question. Okay, so writing the entire mechanism and finding out the product would take a lot of time. Okay, so just by using the logic, even if you don't know the name of the reaction, you can solve this question. Okay, so first thing here, if you see, this is cyclohexane ring that is attached to nitrogen. Okay, cyclohexane directly attached to nitrogen. Here you can see cyclohexane is attached to carbon, carbon. So two options are already eliminated. Okay, it is not a cyanide. We have to use a isocyanide. Now these two reactants are also same. What is different is the first two reactants. How do you check? Here, if you see in the product, after this ring there is one carbon, two carbon, and then there is a nitrogen. Okay, there are two carbons and then there is a nitrogen. Here there is one carbon and there is an aldehyde group. Okay, so which is going to be the correct answer? Correct answer is going to be option A. So what is the correct answer for this question? It is going to be option A. The only thing that you have to do in this question is you have to analyze the reactant, see the product, the bond connectivity, and you can easily answer this question. Next one, the major product formed in the following reaction is. Now heat is given. Always remember whenever heat or light is given, you have to understand that it is going to be a free radical mechanism. Okay, it is going to be a free radical mechanism. Now this is AIBN is what? It is a radical initiator. Okay, it is a radical initiator. So how will the reaction proceed? Let us write down the reactant first. Here I have oxygen, O, and here we have iodine, oxygen, double bond, and R. Now what we have to do? We have to do homolytic cleavage. We will break both these bonds. What do we get? Here this I minus will go away. We will get a radical here and we will get a radical here and here. Suppose I consider this radical as pathway A and this as B. Okay, so if I use the radical A, 1, 2, 3, 4, 5 and 6, I will get a 6-membered ring. And if I use the other radical that is B, then I will get 1, 2, 3, 4 and 5-membered ring. Okay, and always remember it is experimentally found based on the enthalpy and the entropic factors. Enthalpy and the entropic factors, it is found experimentally that a 5-membered ring is more stable as compared to a 6-membered ring. The 5-membered ring will be formed. Okay, so the pathway, the blue colored pathway will be followed. Okay, these two radicals will combine and we will get a 5-membered ring. So what will be the final product? The final product will be this ring remains as it is and we get a 5-membered ring. Okay, and we don't know the stereochemistry, so it is written like this. We don't know the stereochemistry at this carbon. What will be the stereochemistry at the junction of the two rings? Okay, this is a fused compound. So always remember, this is a very important stereochemistry trick that at the junction of two rings, for 4-membered ring or greater, always remember that at the junction, it will be always cis. Okay, it will be always, the stereochemistry will always be cis. Okay, so it will be both the hydrogens are above the plane like this. So what is the correct answer? 5-membered ring. So 6-membered ring options are incorrect. 5-membered ring, here it is cis. Here it is, both the hydrogens are trans. You can see one is above, one is below the plane. Here both are above the plane. So the correct answer is going to be option B. Next one, the reaction of PPH3 Cl2 with PHNH2. So this is taken from a reference book, that is Greenwood and Earnshaw, second edition. This is the page number. You can see this is the reaction. Now let us see how this reaction proceeds. So I can write down the structure of this PH3Cl2 pH and I have PHNH2, that is aniline. Now this nitrogen has lone pair, so it can form a substitution reaction. This will attack. Cl will go away as a leaving group. So what we will get? We will get P NH2 pH. Nitrogen gets a positive charge since it has formed 4 bonds. pH, pH, pH and Cl. Now what is the next step? Next step is one NH2 I can write like this. Okay, so the Cl minus that I have removed, this can pick up this proton and it will give back the nitrogen its lone pair. Okay, so what do we get? H, and nitrogen has got its lone pair. Now next step is this can form a double bond here and Cl will go away as a leaving group. Okay, and nitrogen gets a positive charge. Now positive charge on electronegative atom like nitrogen is unstable. So again the Cl minus will abstract this proton and give nitrogen back its lone pair. Okay, so what we will get, this is the final product. This I can write it as P BPH3 double bond N pH. So what is the correct answer? Correct answer is option A. Let us see the next question. For the conversion of this is the complex that is given and we have to convert it into this. So let us write down the complex first, the reactant that is given PTL, then we have Cl, Cl and Cl. And what it gets converted to trans. So both the Cl are trans to each other. Which are the other two ligands? One is L and H2O. Okay, so now the question is the trans effect is least. So this is a question of trans effect. What is the trans effect? It gives the order for the substitution of this Cl with some other ligand L. Okay, with some other ligand. Okay, that is water. Okay, so we have to substitute this Cl with water and this is the directing ligand. Okay, this ligand is going to determine the rate of the reaction. This is a which reaction? Reaction of a square planar complex. Okay, so this is the effect, directing trans effect series. This you must know. Okay, if you don't know this order, then you cannot solve this question. Trans effect, this I have taken from which book? I have taken from Missler and Tar. Here if you see there are A, B, C, D, 4 ligands are given. Okay, this order determines the rate of the reaction. Okay, so what we have to consider is we have to consider suppose if it was a CN then the rate would be maximum or the probability of substitution will be maximum of the ligand trans to L. Here you can see water is at the last. So if the L ligand is water then the rate will be minimum. So the correct answer is going to be option A. Let us see the next question. The acetylysis product of the given reaction is. Now this is a very good leaving group and pH is what it is benzenery. So here which reaction will take place? This pH or benzene can undergo NGP reaction or we can say it is also called an anchimeric assistance. Anchimeric assistance. Now what is NGP? NGP is neighboring group participation. Neighboring group participation. Neighboring group participation, that is NGP. Okay, so this NGP can be carried out by a species having lone pair. It can be by a double bond or it can be also by a benzene ring or it can be also by a single bond. Okay, here it is going to be benzene ring. Let us see the mechanism. pH, I can write it as like this. pH, OTS, both the methyl are cis. CH3, CH3. So what will happen here? The benzene acts as a group that will help in the increasing the rate of the reaction. So this pi bond can attack here and OTS will go away as a leaving group. What we will get? we will get a three-membered ring. Okay, what we will get? We will get a three-membered ring like this. Okay, positive double bond, and both the CH3 will remain cis. Okay, so this is the intermediate that is formed. And now here we can do next step. Next step will be OAC minus will attack here, and benzene will get its aromaticity back. Okay, so what will be formed? There will be two products that are formed, pH, OAC. Okay, the main important thing is the stereochemistry of both the methyl groups will not change. Okay, either both of them will be below the plane, or both the methyl groups will be above the plane like this. OAC. So which are the two correct options where both the methyls are cis? Okay, so what is the correct answer? Correct answer is option A, comma C. Let us see the next question. This is from nuclear chemistry. Okay, so what is an alpha particle? Alpha particle is helium nuclei. What is the atomic number? 2. Mass number is 4. So 60 plus 4, we have to add the atomic number and atomic mass number to get P. What is P? P will be atomic number is 28 plus 2, 30. Mass number will be 60 plus 4, that is 64. We have to follow which rule? We have to follow the law of conservation of mass. Okay, so P is this. Okay, it is an MSQ. Is or are, that means more than one option are correct. So P option is correct. So what is P? P is Zn 64 30. Now next is neutron. What is neutron? 1 0 plus Q. What will be the mass of Q? Here there is 1. 63 is equal to 1 plus, sorry, 64 will be 1 plus 63, and 30 will be 0 plus 30. Okay, so Q atomic, for Q the mass number is 63, atomic number is 30. For Q, mass number is 63, correct. Atomic number is 30, that is also correct. So this is also correct. This is which element? Zinc. Next is there are two neutrons. Okay, so 64, this will be R. Okay, 64 plus, this is 2 into 1. For understanding, we can write this as 2. Okay, so 2 plus what will give us 64? 2 plus 62 will give us 64. And 30 plus 0 is, we need 30. 30 plus 0 will be 30. So R is 62 and 30. R is 62 and 29. So this is incorrect. Last one. Here we have one proton. What is proton? It is hydrogen atom. Mass, atomic mass is 1. Atomic number is also 1. Neutron, mass is 1, charge is 0, plus S. Now 64 will be 2 plus 62, and here it is 30. So 1 plus 0 plus 29. Okay, so S is 62, mass number is 62, atomic number is 29. So D option is correct. So what is the correct options? Correct answer is A, B, and D. Now this is the next question. Major product formed in the given reaction sequence is. Okay, so there is this benzene, C double bond O, N minus, K plus, C double bond O. Now here this will react with this reactant that is given, Br, C double bond O, pH. How it will react? N minus will undergo substitution reaction here. Okay, Br will go away as a leaving group. So what we will get? We will get benzene C double bond O N, CH2, C double bond O PH, C double bond O, like this. What is the next step? We add NaOMe. Okay, this can act as a nucleophile. Okay, OMe, this will attack here. This will open up O minus. Negative charge will come back and this bond will break like this. So what do we get? We get a negative charge on nitrogen. Okay, that will pick up proton and it will become an amine. So what do we get here? Here we get an ester. C double bond O OMe. Now NaOMe, this can also act as a base. Okay, so it will abstract this acidic proton. Okay, OMe will abstract this proton and we will get a enolate. Negative charge. Now we can do intramolecular nucleophilic substitution. This minus sign, okay, this enolate can attack the carbonyl carbon which is electron deficient, delta plus, delta minus. This will open up O minus and OMe is a good leaving group that will go away the leaving. So we will get 1, 2, 3, 4, 5 and 6 membered ring. What do we get? Benzene and a 6 membered ring like this. Let me number 5, 4, 3, 2, 1, 6. Okay, first carbon there is C double bond OPH. Second carbon there is nitrogen. Okay, so I can write nitrogen here. Then third carbon there is C double bond O. Fourth, fifth, sixth carbon there will be C double bond O. Okay, so can you see the product? Okay, no, none of the options are similar to this. So what we can do, here there are two keto groups. We can do keto-enol tautomerism. Okay, so keto we can make enol form. Okay, this will become enol nitrogen, enol. Both the ketone groups we have made it enol. And here we have C double bond O pH. So this is the final product. Which is the correct option? The matching option is option B. Correct answer is option B. Next, this is the question of steady state approximation from chemical kinetics. Okay, IA represents the intensity of the light absorbed. So this is a photochemical reaction, first step. And assuming the quantum yield for the first step is 1, the steady state concentration of Q will be what? Okay, so we have to find out the concentration of intermediate Q using steady state approximation. Okay, so first what we can do, how do we write down the steady state approximation? So according to the steady state approximation, if I want to write down for the formation of the intermediate, dq by dt will be rate of formation of Q minus rate of decomposition of Q is equal to 0. Okay, so how we will get the answer? First is rate of formation. Where Q is formed? Q is formed in the first reaction, that is the photochemical reaction. So for photochemical reaction, it does not depend on the reactant concentration. It only depends on the intensity. Okay, IA. And now it is getting decomposed in two reactions. One is, let's say this one. Okay, 2Q getting converted to P2. Rate constant is K1. Okay, so IA minus, okay, we have to first write down the coefficient of this. That will be 2 into rate constant is K1 into concentration of reactant is Q. Its stoichiometric coefficient is square. Okay, that is 2. So we write square. And it is also getting decomposed in this reaction. So minus 2 K2, then write down the concentration of reactant, that is Q square is equal to 0. Now we have to rearrange this equation. Okay, so IA will be equal to this. I can bring on this entire thing I can bring on the right hand side. IA will be 2K1 into Q square plus 2K2 into Q square. Okay, we want the expression for Q. So I can take 2K1 plus 2K2 as common Q square IA. So what will be Q? Q will be IA, Q square will be IA divided by 2 into K1 plus K2. Okay, and what will be Q? Taking square root, we'll get the value of Q as root of IA divided by 2 into K1 plus K2. This is the final answer. So the correct answer is going to be option A. I hope you have understood this solution. We will see some more questions in the next part. Thank you.